So we're gonna try a new video technique. Hopefully the audio is better. I'm still having some issues, so if it gets bad, I'm so sorry. We'll just kind of deal with it. So we're talking about inverse trig functions, right? So you may recall from chapter 1 when we talked about inverse functions that there's more to just switching your x and your y, right? A function has an inverse if and only if it is one-to-one, meaning it is a function, so it passes the vertical line test and it passes the horizontal line test. So if we look at the trig values here, functions here, sine, it fails the horizontal line test everywhere. So what we're going to do, kind of similar to what we did with parabolas and absolute value functions, is we are going to limit the domain of this function so that it does pass the horizontal line test. All right, so looking at sine f, how can we limit the domain so that it does pass the horizontal line test? Well, if you take kind of half of a wave here, as illustrated here, you can limit the domain so that it does pass the horizontal line, right? So if we're talking about just sine of x, the domain, we had what? Well, we're going to limit the domain to be negative pi halves to pi halves. The range is negative 1 to 1. So that means when we talk about sine inverse, those are going to switch. So sine inverse's domain is going to be that negative 1 to 1. And its range, or the angles it gives, so sine inverse is going to give angles, what does that really mean? Its range is going to be from negative pi halves to pi halves. Okay? We're going to do that with all of our trig values here. All right, so if we look at cosine, how can we limit the domain of cosine? Well, looking at this piece from here to here, we can limit the domain. So cosine inverse is only going to give us values between 0 and pi. So what that really means, thinking about this on your unit circle, it's going to give you answers in quadrants 1 and 2. If you think about sine inverse on your unit circle, it's going to give you quadrants 1 and 4, negative pi halves to pi halves. Tangent, you can just limit by looking at one wave tangent. So by looking here and just looking at this one period tangent, you can limit the domain so it passes the horizontal line test. So we limit the domain of tangent to be, once again, negative pi halves to pi halves, but this time we're going to have soft, because recalling what do we actually have there? So they're not going to be included. So once again, thinking unit circle, that's going to give us answers in quadrants 1 and 4, but it's not going to include your negative pi halves. Similarly with cotangent, you're going to limit it from 0 to pi, right? So all of your answers there are going to be from 0 to pi with soft brackets. Cosecant and secant are a little trickier to identify here. How can I have the largest domain possible that still passes the horizontal line test, right? And so what you actually do there is you're going to take this half of this and this half of the upper. So we are limiting, once again, from negative pi halves to pi halves, and this would be inclusive. So thinking on your unit circle, 1 and 4 again. So that means whenever you're evaluating a cosecant value, or a cosecant inverse value rather, you plug it into your calculator is going to give you an answer between negative pi halves to pi halves. and that'll come into play later. All right, and finally, secant theta. Similar to cosecant, we're going to limit it using half of a parabola of each parabola there. So here we are going to limit it from 0 to pi inclusive, which on your unit circle would be 1 and 2. So you should hopefully have noticed a pattern. Let's see here. We have 0 to pi, negative pi halves to pi halves, 0 to pi, negative pi halves to pi halves, 0 to pi, negative pi halves to pi halves. Your two options for limiting the domain here are negative pi halves to pi halves, 0 to pi. It's just a matter of figuring out which ones work best. All right, so going back to our notes. Inverse trig functions. Well, if we limit the domain of sine to be between negative pi halves to pi halves, its range would be from -1 to 1. So what does that look like graphically? All right, well, sine of negative pi halves, sine of 270, really what that's asking, it's going to be down here at -1. Sine of 0 is 0, sine of pi halves is 1. You really have this piece of your sine curve that we used earlier. So what happens when you have sine inverse of x? Well, your domain and range, as with inverses, are going to switch. So your domain of sine was negative pi half to pi half. That's going to be the range of sine inverse. Your range of sine was -1 to 1. That's going to be your new domain. So graphically, that's going to look, so over here we have negative pi half, -1. Switching your x and y, that's from -1, negative pi halves. 0, 0 still remains 0, 0. And pi halves 1 becomes 1 pi halves. So that would look something like this. They are still going to be reflections of each other over the line y equals x. And they will still have those domains and range switched. Okay, so continuing on with cosine, using a similar method there. Thinking about cosine, we limited the domain to be from 0 to pi. Its range is still -1. All right, so cosine of 0, we're at 1. Cosine of pi halves, we're at 0. Cosine of pi, we're at -1. So we have struggling on my computer here. This piece of the curve. So now when we do cosine inverse of x, well, my new domain of cosine inverse is going to be -1 to 1, switching, and my range is going to be 0 to pi. So graphically, I go from -1 to 1, and I'm going to go from 0 to pi. So switching these, instead of 0, 1, I'm actually going to be a 1, 0. And instead of pi halves 0, I'm at 0 pi halves. And then instead of pi -1, I'm at -1 pi. And I will have this piece of my. Okay, so I'm going to stop this video so I can move on because I'm approaching my limit. And once you're finished with this, go ahead and go to the second video.